Hello and welcome to another episode of the AgNext Podcast, where we are always excited to tell you about what is next from AgNext. Today we are joined by Dr. Juan Vargas to discuss his recent publications on methane measurement and cattle performance.
Welcome, Juan. Before we get going, can you take a minute just to introduce yourself to our audience, please?
Okay, thank you, John and Kim, for inviting me. Yes, my name is Juan Vargas. I'm originally from Colombia. I complete my undergraduate program and my master program in the National University of Colombia. And then I work a little bit, like 4 years in the Research Institution Center in Colombia as a researcher. And I have the opportunity to complete my PhD in the University of Florida, working with Professor Nicolas de Lorenzo in background in diets there, in ruminant nutrition. And in 2023, I have the pleasure to be here with you, working, analyzing data, and learning with you those new topics.
Awesome. Thank you, Juan. We're excited to have you on.
Thank you.
Today we'll be speaking about 2 publications that have come out recently, focused on studying the gas flux of animals in both confined and grazing systems. Why was this research needed, and how does it help advance science-based sustainability in livestock?
Yes, I think it's important to understand that all human activities has an impact in the environment. So we are aware of those situations, and we try to understand and develop new strategies to reduce that impact from the livestock, especially from the ruminant production system. So one important impact is the gas production, especially methane emission. And we need to understand and develop new methodologies and new strategies to reduce those emissions, especially methane. And one important technology that came up maybe 10 years ago is the use of automatic head chamber system. And we need to develop a methodological approach to understand those emissions under a confined and under grazing condition. So the first objective when we start to analyze that data was to develop that methodology in a systematic approach to understand how many visits those animals require for 2 reasons. One, to understand the metabolism, the energetic metabolism of those animals, but also to properly quantify the emission of those animals under those circumstances. So that gives us some confidence to evaluate those animals, identify those animals, and also to evaluate different strategies to reduce greenhouse gases in those conditions.
What does that mean? Help define for our listeners when we talk about gas flux. What does that mean? Because not everyone is trained maybe in animal sciences or greenhouse gas emissions. And so what is gas flux? What does it mean? How do we measure it?
Yes, we can measure with different methodologies. The automatic head chamber system allows us to identify the production of methane emission, CO2 emission, hydrogen emission that is produced during the fermentation or respiration of the animal, normal metabolism of the animal, but also oxygen consumption that is related also with the metabolism of that animal. So in general, gas flux is the amount of gases that the animal produce daily in a normal condition, and allow us to identify the energetics and also to identify potentially the production of those greenhouse gases that we want to at least reduce from our system. So that is gas flux in a nutshell.
Great. And Juan, I want to go back. I have some questions. So you've described what gas flux is. How do emissions or gas flux vary within different production systems? What do you see?
Yes, in general, it's well recognized that animals under grazing condition or consuming high forage diet produce more methane. And in those conditions, in high forage diet, dry matter intake is the main driver of at least methane emission. So, however, when the animals are consuming a high concentrated diet, especially during the finished phase, that methane emission is not related with dry matter intake. So the idea is to identify those animals, and we noticed that animals under grazing or consuming high forage diet produce more methane, more or less around, it depends on the diet, but around 200 and 300 grams per day. But animals under confined condition maybe could be half of those emissions. So those are important characteristics of the system, but more important that the system per se is identify those animals in each system that produce less, or some practices that we can implement in those systems to reduce greenhouse gases. So, but there are variability between animals, but also between management condition.
What kind of variability do you see between animals?
Between animals under the same condition could be 30 to 40%. In the same condition, same management, but animals can produce 40% more or less. So we can exploit that variability to identify those animals.
So the perfect purpose of this study was really to understand methodologies, to make sure that our methods were robust and appropriate to detect differences between animals that you're identifying, that variability, but also differences in practices or production systems. You said you were using automatic head chambers. Mm-hmm. Can you describe that methodology, so that technique to measure gas flux, and then can you compare those to the other techniques that are available?
Yes. In general, there is a gold standard methodology that is the indirect head chamber, to collect all the gases that the animal are producing. And some years ago, maybe 5 years ago, there are a lot of evidence that automatic head chambers can be used to also determine gas flux from those animals. So there is a good agreement between methodologies. And the head chamber is simply is a feeder that the animal can visit in our condition voluntarily. So the animal visits voluntarily. There is a fan that collects the gas surround the head of the animal, and we can estimate the methane emission or the different gas flux from that animal that visit that feeder. So we found in our analysis that we need more or less 55 visits to represent 100 visits from that animal, the emission of 100 visits for that animal. That approach we use and is used for other variables when we evaluate during long time periods. It depends on the system, but we define 100 visits, and we start to correlate how many visits those animals require to represent the 100 visits. So we found that 55 visits are required to represent the emission of those animals, although in grazing and in confined condition.
55 visits?
Yes.
For confinement and grazing?
Yes. And of course, I want to clarify that we did a previous or an initial evaluation in grazing, and we found that 70 was required. But in this initial evaluation, we have limited number of animals. So for that reason, when we include more animals in the analysis, maybe those numbers or the visits will change. But the most interesting for me is when we have the opportunity to collect more data and to evaluate more animals, I think we will be more precise. We will do recommendation more precise for producers or for researchers.
So that's interesting. I want to go back a little bit as well. You talked before about energetics,
yep.
Right? And so the importance of energetics in the science of all this. And so maybe can you talk about, maybe again, just define what we mean by energetics, but then talk about how energetics play a role in methane emissions, but also performance indicators, and how intake, growth, methane emissions are all kind of tied up and related to energetics, and how we can use that right? Your methodologies help move that forward.
Yes. In general, is when we analyze or we evaluate energetics in an animal, methane emission represent an energy loss for the animal. That can vary, but it's around 6% of the gross energy intake from that animal. So if we account for that energy that the animal lost, we can identify more efficient animals. That is one way. The other way, from maybe experiments in the 60s using complete indirect chambers, we can estimate heat production using the CO2 production from that animal, O2 consumption, and methane, to estimate the heat production of that animal. And then using the factorial energetic approach, we can estimate the retained energy. So there are different ways that we can use those gas flux to identify those animals or practices that are more efficient and promote more or less loss, or promote more retention, energy retention for that animal. That is one approach that I think maybe the last year is more, there are more research in that area. But also we identify with the analysis, with a different analysis that we are doing, that if we classify animals according to methane production, for example, as a low and high methane production, maybe we can also affect those groups, because as I mentioned before, methane production is related with dry matter intake and gain. So if we select animals only to reduce methane, maybe we are affecting productivity. So we need to evaluate the different approaches to select or identify those animals with less methane production, but also without affecting or increasing performance from those animals. Yep.
And do you do that in all the studies, Juan? You measure dry matter intake and average daily gain along with the gas flux?
Yes, in confined condition. Mm-hmm. Under grazing is pretty hard.
Yes.
However, we collaborate with University of Florida trying to address that question. And we use CO2 to estimate dry matter intake. And we found a very good correlation of using CO2 to predict dry matter intake in a high forage diet. So that is very interesting, but we need to prove actually under grazing condition. So that is an experiment that we need to do in the future.
That's exciting.
Yep.
So talking about experiments, what do the results of these two publications mean for research from through a practical lens to get 55 visits in confinement? Is that easy to do? Is that difficult? And then I want you to answer the same question for grazing.
Yes, for confined condition, we observe that in average, our animals in our condition visit the automatic head chamber 2.3 times per day. Mm-hmm. So 55 visits is more or less 25 to 30 days to achieve that threshold.
Sure.
So it means that we need 1 month to evaluate one animal to appropriate determine gas flux. However, under grazing condition is very challenging, because that varies according if the animal has been exposed to the unit, how are the conditions in the paddock or the management of the grazing. So that is more difficult, and in our evaluation, more or less the animal visit 1.3 times the automatic head chamber. It means that require at least 2 months.
Yeah.
In the best, at least.
Right.
So it's difficult, especially if you want to evaluate transition management or short-term interventions. So that is very important to understand, and those analysis has been conducted using the condition that we are working on. In different conditions, maybe it's a different recommendation. For example, is well reported, the first report using automatic head chambers in dairy, when you move the automatic head chamber from to each animal. So maybe in 3 days you can collect all the gas
because
flux.
she has unlimited visits.
Because you move and you push each animal to visit. But when you allow the animal voluntarily visit the unit, it's more difficult. But I think could represent better the natural condition. So that is important to understand, to conduct an experiment or to actually have a very good measurement of gas flux.
Great. And then for the graduate students that might be tuning in, or a research project that may have fewer animals, what do you do with the animals that have less than 55 visits? It's still data, especially in grazing systems. What would be your recommendation for that data?
Yes, I think there are 2 publications, very nice publication, that suggests that maybe using less visits could be useful also to represent the methane emission. But the importance of the number of visits, more than the number of visits, should be represent the daily emission from those animals.
Sure.
So if the visits that the person, the researcher or the graduate student are evaluating represent the daily emission, and more or less is a continuous or more or less homogeneous management, I think could be useful.
Yeah.
However, it's important to describe in the methodology because the majority of the occasion, people or researchers do a very poor job sometimes describing the methodology. So if you are aware of those situations or those limitations, you can maybe explain. However, we feel very comfortable with 55. Also, sometimes it's very difficult to achieve. Yes, I know.
I know. I think in my grazing trial this summer, we had 120 visit and only 50 had 55 visits or more for the entire grazing system.
Yes. And we noticed,
painful.
Yes, and we noticed that if the animal is accustomed with time.
And they were.
Yes.
They've all used it before, and we
Yes.
still had low,
Yes.
good visits, right? 100. I mean, all of them visited voluntarily, but continuously 55 times
Is
over the grazing, very difficult.
Yes.
Yeah, it's really interesting.
Good luck. So now that you have some methodology in place, right? So we've got, as you said, this is a relatively new technology. We're still kind of figuring out how the best practice is to use that to get the results that we're looking for in these research trials. With these new methodologies that you've come up with, we're better able to compare animals and determine those lower emitters, right? For some given level of production or yield or intensity. So can you speak a little bit to how this now allows the industry to start selecting for lower emitting animals, specifically in both grazing and confined settings, because we know that, right, we need to control emissions in both if we want to have an impact. And so talk a little bit about what you think we can do from that standpoint.
Yes, I think these methodologies, defining appropriate methodologies are important, especially to have some tools to select animals or identify practices. However, it's important to recognize the limitation of each technique and the characteristics of each system. And I want to explain a little bit more about that, because we notice that when we evaluate animals during grazing, for example, and we recognize low emitters animals, those animals doesn't emit the same in finishing phase. So we start to realize that there are some re-ranking when we evaluate those animals in different conditions. So we need to be aware of when we need to evaluate gas flux if we want to select for reducing methane emission. We need to be careful about that, because maybe if we select only animals that emit less during the finishing, maybe those animals behave differently during the grazing period. So we need to do more research in that area. Maybe the appropriate way is to identify those animals that emit less under grazing if we want to use those animals in those conditions, and maybe differently for finishing phase. That is something that we need to discuss a little bit more, but I think the methodology will help us to take some decision, but it's not very clear, at least for me right now, which is the best approach to select animals.
It's hard. Yes. It's hard to think about the fact that we might be selecting a low-emitting animal for grazing, but that they might be a high-emitting animal in confinement, or higher, maybe not the highest, but
yes.
that we might have to jump a whole sector of the supply chain. I'm looking at our economist here to incentivize something that has the opposite effect in confinement. It could be really interesting to see. Yes. Juan, this is off of our script, but I want to ask, to John's point, so if we're thinking about energetics and we have the opportunity to select a low-emitting methane animal, what does that mean for animal performance potentially on the landscape?
Yes, we observe that animals that produce less methane and grams per day usually is associated, especially under grazing condition, with animals that consume less and gain less.
Yeah.
So if we select only for production of methane, maybe we are affecting performance. But if we use a different metric, for example, methane intensity, that is the grams of methane per unit of gain or residual methane emission, that allows us maybe to identify animals that produce less methane without affecting performance. And I believe that is a better approach to promote sustainability in our system, because we are selecting more efficient animals. I know that some groups are very reluctant to residual methane emission, but I think we need to explore more that approach to evaluate if those animals actually produce less methane without affecting performance, and that could be super interesting, I think so.
Yeah, I think that's what I'm most excited about is, can we select an animal who's actually more energetically efficient in a grazing environment and use methane as an indicator of energy loss? And then maybe that solves the incentive challenge that we were just discussing.
And I think not only methane in that case.
Absolutely.
Heat production that we can estimate using CO2 emission and O2 production. CO2 production and O2 consumption. That allow us to be more refined, identifying those animals that are more energetically efficient.
Absolutely. So we, just to bring this back for the listeners, because I went down a little bit of a rabbit hole there. How does this apply to sustainability? Kind of big picture. Why is this type of research important through the lens of sustainability?
I think the farmers in general are feeling a lot of pressure for the society to implement practice to promote sustainability. And one important aspect is the emission of greenhouse gases. One of them is methane emission. So if we can provide different methodologies and different options to evaluate those animals, identify practices, identify animals that help the producer to be more efficient. And if at the end those practices result in more efficient or more productivity, that is another aspect that we need to evaluate. That is a win-win situation when we promote sustainability of the system, but also the producer will adopt that technology because that results in more profitability for them. So I think at the end, it's not only science that plays here, is always the opportunity to work in a multidisciplinary group, as we have the opportunity here in AgNext, but also have the contact with the producer to actually adopt those technologies. If we can do that, it's very hard. If we can do that, I think that will promote sustainability in our system. Yep.
That's great. It sounds like you're not done yet, right? In this work. And so my next question is what's next? Where are you going from here? What have we learned, and what do we still need to learn in this research?
Yes, I think there are different avenues. I think one very important is to explore a little bit more about the energetics and the use of this technique or this system to properly determine energy expenditure or identify more efficient animals. Other avenues, and for me is very passionate, is understand a little bit more about grazing condition. I think we lack a lot of information under grazing, especially in the cow-calf sector. And it's very interesting because apparently no, the estimation is that methane is produced majority in the cow-calf sector. However, we don't have a lot of information in that sector. So it's very intriguing, that kind of situation. But so if we can explore energetics, if we can refine the emission from those sectors that we miss information, and if we can develop some management strategies easy adoptable for producers, I think those three different avenues are very useful from an animal perspective, for a business perspective, and I think will increase the sustainability of our city. Of course, maybe I'm missing a lot of other opportunities, but that is also the job of all the team. It's not only mine.
Yeah, I'm especially excited about the grazing work as well. And I think my new dream is that the energetic efficiency could allow us to potentially select a drought-tolerant cow. And I think that could be pretty cool.
Yes, I think it's very interesting question, research question. We can explore a little bit more in the future.
Yeah, so it may take us the rest of our careers, but it's exciting stuff.
Yes.
Juan, thank you so much for joining us today. And to our listeners, thank you for tuning in to another episode of the AgNext Podcast, where we are always excited to tell you what is next from AgNext. Don't forget to follow us on Facebook, X, LinkedIn, and Instagram. For feedback or suggestions, email us at agnext.colostate.edu. Thanks for tuning in.